Okay, so I'm Paul Prueitt. I'm going to have a lot of slides here that I'm going to move fairly quickly through because the technical discussions are extensive. Essentially, the proposal is to use neuroscience, technology, and pedagogy to create an infrastructure for the delivery of inquiry-based learning methodologies to all students who are studying mathematics and science, and to, in some sense, open up the doorway to higher mathematics to those students who are not now being enfranchised. So we understand there's a lot of disenfranchisement coming from the school systems into the college. So I call this individually directed inquiry, and the proposal is to create a mediating social media, actually in 3 dimensions, using OpenSim or Unity 3D. This attempt to outline a future machine-based software interface that might support individualized inquiry-based learning. So part of this is to look at the immunological and neurological models of learning as a potential basis for large-scale integration of adaptive assessment and self-directed inquiry. Now, we all are scientists here, so we recognize that even as mathematicians, of course, the language of science is mathematics. Most of us will believe that we can't access mathematics and we can't access science unless we have a deeper understanding of mathematics, say, for example, through linear algebra and through set theory, probability, and statistics. So there is in some sense, notion of a common course for the first 2 years of college, which I believe, and I think most people here believe, everyone should have the ability to have access to that. And so we're going to look at what the issues are here. My work is exploratory in nature. It's 30 to 40 years old. In 1984, I made a conjecture that an acquired learning disability that would be neurologically measurable was being acquired by most students as they went through our educational system. So that by the time they became freshman students, they were no longer capable of doing things that they were capable of doing in the 4th and 5th grade. So that's part of the conjecture. The community of R.L. Moore legacy professors should play a central role. I was trained at the University of North Texas in topology and measure theory. After doing the qualifying exams in those 2 topics, I studied with John Neuberger, the wonderful mathematician, in numerical analysis. But the qualification in topology and real analysis wasn't leading me into a dissertation. What I was interested in was why were my freshman students not interested in learning mathematics? So in middle of the 1980s, you have to remember that neural networks was even just beginning, and artificial intelligence and the whole evolution of those kinds of things. So I switched to another university, worked with Professor Dan Levine, who is a Stephen Grossberg student. He's the founder of the School of Artificial Neural Networks. So my model was on the brain ability to learn, given that we have frontal lobes and limbic system, associational cortexes, and we have an immune system. So it's a self, not self structure. We're going to start with some very basic observations. The human perceptual system is complex, but in recent decades we have seen details about mechanisms involved in emergence and emergent behavior. Now, emergent behavior is non-Newtonian. So the first thing is that differential equations are probably not going to do it. Now, Walter Freeman, of course, a colleague of mine at Berkeley, developed a partial differential equation model. But in that model, he sees the brain as an entire system, as one system. So the artificial neural network community as a very complex community. I won't be able to talk too much about that, but complex systems is essentially what we're talking about. So what is non-locality? Is there non-locality? What is emergence? And then interesting enough, what is induction? Now, physical induction, mental induction. So these are some deep questions that we try to bring together. Awareness, memory, and anticipation. Memory is from the past. Anticipation is about the future. Awareness is the present. So we begin to see some principles here in theories of consciousness associated with how does the self experience awareness, memory, and anticipation. Learning involves three systems. The neural system is integrating memory and anticipation in contextualized experiences. And it does that through coherence and through induction and emergence. So again, these are all, to begin with, non-Newtonian. You're not going to get a full model of this using partial differential equations, Stephen Grossberg and embedding field theory set aside. We see that there is something about the routes to chaos as one way of indicating it. I mentioned Prueitt's work on the end of certainty. I don't know if you all read the book, End of Certainty. But the ideal is that science reaches up to a certain point, and then it's not able to deal with certain questions. Emergence, the notion of coherence, so the neural system is there, it's integrating memory. The immune system creates this sense of self, what Matrani and Valari call audiopoiesis, right? So we don't perceive reality directly. We will see is, according to classical theories of consciousness, what we see is our internal mechanisms reporting, okay? So we look at the retina and the lateral geniculate nucleus and then the visual cortex, and then where are we experiencing what we're perceiving? So these are the kinds of questions that we work with in complex systems. So we envision a digital neural architecture for cognitive support for social networks. Now LinkedIn is doing this already, but the proposal is to actually create an architecture also for a digital immune system. Now the digital immune systems, this comes from Stephanie Forrester, Santa Fe Institute, and others. The digital immune systems are all about cybersecurity in a world in which everything is fully instrumented. So the social media that we're proposing is a fully instrumented social media, which means everything that happens is aggregated into ontological representation of event structure. Now they do that in military combat. That's how they fight wars. Or in the world of terrorism, you have the analysis of all social discourse in Islam, for example. That kind of structure is what we're proposing to embed in this. So we have this immune system architecture. This is an architecture I put together for the Air Force. We have a target network. We have output files. We're going to do big data analytics on that kind of thing. We have pattern extraction, and then we have pattern recognition. But we also have things that we've never seen before. So one time General Alexander was talking about he wanted to know what was in his data. And I looked across at him and I said, General, what you want to know is not in your data, because you have a way of structuring data so that it becomes an SQL structured database. And this was before the kind of new revolution in which non-SQL type data analytics was being performed. Of course, Hadoop and Hive and all those new kinds of systems that they have, those are all non-SQL. So it's real-time identification of structure, real-time use of identified structure in order to create pattern recognition. You have self, not self, and then if there is a threat to self, you shunt that over to an immunological school, essentially. There's something out there that I do not know and I am not seeing. I need to know that I do not know something. Let's say this recent thing where Al-Qaeda has attacked Iraq and is just decimating nobody's anticipating that because nobody saw it, right? Well, they did see it, okay? So who saw it and what's happening, what's all the mechanisms underneath there? All of this needs to be applied to the educational processes. So here's some of my work on adaptive resonance theory. This is Stephen Grossberg's work on essentially, this is the biologically feasible neural networks, not simple backpropagation networks or backpropagation of error networks. Paul Robles has been a good friend of mine for a long time, but this is much, much more complicated. This is Dan Levine's, my PhD advisor's model of gist formation. Now, gist. Oh, these are the equations. They're all first-order differential equations, foxes and rabbits, right? So if you have foxes and rabbits, rabbits are being eaten by foxes, foxes are eating rabbits. If you have a low population of foxes, the rabbit population goes up. So you can write differential equations. This is Rashimsky's work on biomathematics, essentially. All of this is in there. You've got inputs, but it's all first-order differential equations. Okay, so what is the gist of mathematics? When asked, most students express disdain towards mathematics. That's the meaning that math has to them, disdain. Now, if you start out with that in your freshman class, as we all have, then what can you do with this? It's not about teaching them anything, it's about changing the gist. How do they form meaning associated with this? Okay. So gests are built from common experiences. What are the common experiences of students in math class? I've had kids where they tell me, well, you know, I was beaten on the hand with a ruler in the 3rd grade. And since then, I've hated math. It was a math teacher that did it. So we have this psychological dimension to the problem that we're trying to adjust. The gist is incomplete and psychologically associated with poor experiences in math class, this gist. So there's a notion of an incomplete gist. Now, so we begin to see that the notion of gist has to do with coherence, right? How can I coherently understand the world, make sense of the world? Okay, so getting the gist of mathematics right. Well, perhaps the R.L. Moore Legacy Project might be developed to add to improvements that we see in the architectural design of online tutoring systems. Now, I think there's about $10 billion being spent this year. And everybody's doing it differently, and everybody's doing it the same, but they're not doing it right. Okay, it shouldn't be tutoring, it should be mentoring. And it should be based upon an inquiry-based methodology. I mean, you know, I do online tutoring. They want to charge $100 an hour. Well, that's going to work for whom, right? So we need to look at what the venture community is expending on this and what other groups are expending on this. Adaptive assessment. Who knows what ALEKS is? A-L-E-K-S, yeah? So there's stochastic equations underneath that, and essentially what you're doing is you're creating learning pathways, right? So if you have assessment, so let's suppose you have MyMathLab or ALEKS type assessment, and you're moving through. So you need to have this curriculum-constrained, self-directed inquiry where you have a rubric. Now, I'm proposing, let me just stop here. I'm proposing that the rubric is skill, evaluation, and synthesis. And you can't get synthesis and evaluation unless I'm looking at handwritten papers from the students. So one of the proposals I'm making digitally is digitally communicated handwritten messages. And mathtwitter.com is a website that I would be happy to give to you if you would like it, because I own it. So the notion of tweeting back and forth handwritten messages between students as to what this question is, what that question is. So we can take R.L. Moore type methodologies. I teach my students. I work with students. If I ask you a question, we're already cheating. You see? We're already engaging in this process of not requiring you to come up with the question. Now, that was my experience in R.L. Moore. Excuse me. That was my experience in R.L. Moore. When Neuberger came in, it was about what was the question? He was asking us, what was the question? What's your question? And how are you resolving this question? R.L. Moore himself said that there's three entities. There's the student, there's the professor, and then there's mathematics. Now that's interesting because like this, the Buddhist notion of community, or the Christian notion of community and dogma. And then, so what you want is for the professor or the priest to not be in the way of the student learning the mathematics. Now, y'all know this history here. So now here this is going into the theory of deep learning. This is from Russian applied semiotics. Okay, so part of my work was to go and to look at what the Russians were doing with respect to semiotic systems, symbol systems. How do you create symbol systems, computational symbol systems that then look at trying to create analytic processes that tell us about some object of investigation? Well, object of investigation is learning. And in particular, the students who are learning in a way. All right, so focus topics. National Academy, National Association, Council of Teachers of Mathematics have had the topics associated with the core curriculum in mathematics for, what, 2 decades? Now, what is the core curriculum? How many topics are in the core curriculum? Well, nobody can tell because the people who created the core curriculum are not mathematicians. They couldn't tell you what the topics were. Okay, but if you start enumerating the topics, then you put it into a computational world as well as a cognitive world. So now, what's known and what's not known? I got 12 minutes left? Okay. I'm just going to move through this a little bit just to give you an indication. This model, this picture here, is that of the neurology or is that the technology? That picture is of both. This is both how the neural system functions. In other words, when we're perceiving things, we're not putting memories somewhere. We're decomposing them and then creating a set of atomic elements. And then we're doing chemistry. We're composing compounds. So that's the deep structure, and then the immune system here. Okay, if I understimulate a system over and over again, it creates an inability to respond to that stimulus. That's biogenetics 101. Okay, so if we understimulate students for 12 years in mathematics, and then we want to teach them again college algebra, which is what they've already decided that they cannot learn, then what is the response? The response is exactly what you see in your freshman students, in your liberal arts students. So this is the model, this is the cognitive system. And yeah, I think, so what I'm going to try to do, there's probably more than enough questions. I'd like to try to get to the discussion period. So I'd like to, rather than spend 5 minutes in talking questions, so if I could kind of prepare you for some talking points, and let's go into a discussion. I'm going to flip through these so that we can just kind of get a sense. This is a deep adaptive assessment, the ALEX deep adaptive assessment, right? So I'm talking about deep adapt. I want to know what I want to know what the fundamental engrams are. Now, if I know that, and I'll just say this, public because it's public information. If I know the engrams, the talking style of Al-Qaeda, I can hear them through big data analytics. Just like voice recognition, I can hear the community with my ear, or with big data analytics, right? And that's the same thing with when you have this representation of the things that are, and then you have a substructure which is small in nature, and you say everything that is a compound. So we're doing chemistry here. This is Charles Sanders Peirce, okay, and then Robert Rosen. So if you know the substructure is very stable, like the atoms. Atoms are very, but chemistry is not. So we have a combinatorial expression of atoms through some kind of manufacturing process. See, that's what the neural system is doing. And so if we are able to capture this and put this into a scientific context, then we might be able to ground future scientific education, science of education, and be able to move the whole system towards something which is discovery-based methodology. So I'm going to see if I can get somebody else to, anybody have any discussion points that you'd like to question?
Ed Parker,
Yes.
retired from James Madison University and more recently Guilford College. I'm curious to know, here, now, as most people who were in academia for mathematics and taught for a living, but were serious about their teaching, all of the stuff that I've learned about teaching has been experiential. And having taught in the sort of the ultimate context in which you're talking, an open admissions university as my first university job, the thing that I began to spot were those markers that if they could do it, then they took off. But I never was able, I'd be famous if I had, to find out how to make sure that those markers were met.
Yeah.
And they were always language things, and I'm wondering where they fit in the schema that you've shown us here. They're clearly not the atoms, but
No.
they're clearly some amalgam of a special combination of those atoms, and
Yeah, okay, so what the theory is that the substructure, the atoms are very stable. It's like the phonetic system. You cannot change your way of pronouncing words past a certain point unless something very radical happens. So the same is true with belief systems. So the mimetic structure underlying each of us has a unique capability of producing who we are as a conscious awareness person. So we have to shift that. We have to create a shift to where the belief that I cannot learn mathematics shifts. Now, when that shift occurs, and experimentally, this all came experimentally for me, teaching, I would see students shudder. Because I would teach RL more, I taught RL more methodology to freshman students and got into a lot of trouble with a lot of universities and never got tenure. But that process, students would shudder, and I began to go around and see what was happening, and I began to realize that there was a resetting of the neural system, and that's what we were looking for. So if you then begin to look into what the frontal lobes is an executive function, the limbic system is driving things, the association of cortex is doing so-and-so, and you get motivation from here, emotions from there, intellect from there, all of that comes together into a theory that begins to say that if you give a novel stimulus, you can get a different system than if you're using the same one. So orientation to novelty, right? This is General Alexander's question. How do I know what I don't know? How do I know when there's something that I don't know? You see, and I've got a coherent picture of the world. Pakistan will never explode a nuclear weapon. Right? That coherent picture allowed us not to see the fact that they had a program and that they were there, right? So you have to be able to shift the perception of the freshman student, and you can't do that as an individual because everybody else and the society and the families and the media is all working against that. So it's a very difficult problem. It's the shift of perception. So this Buddhist cone, it's a shift. How do you create something? You have to use novelty, first of all. That's the immune system part. I'm not going to orient to dividing polynomials. If I'm a liberal arts mathematics student, it's not going to happen. But if you change the number base and get them to do intersection of parabolas and lines in any base other than the ones that we've been taught. So I'll teach you in base 7 and base 10, we'll maybe do base 5. You choose a base outside of those. You make up the coefficients. See, this is an R.L. Moore methodology. You make up the coefficients. You show me the 4-step method. Give me a name of what it is you're studying, your name. Illustrate that in handwriting, or find an illustration and copy it. Now make a second illustration as different from the first as possible. Now write a narrative. It's called the blank paper test. So my tests were, here's blank paper, tell me what you've learned. Now you can't just throw that on them, you have to prepare them. So they all memorize things. And then you do things like, your paper has to be original. I don't want to see the same problem worked out by 3 different students. Okay, so now you come in, total blank mind, total blank paper, pencil. Blank paper test. When you look at it, you just see them, you put the grade up there. You don't have to look at the arithmetic. Now you begin to discover you can have very beautifully written paper that has arithmetic errors, which is another problem. So there's a methodology here that goes to that. Yes, sir.
Nag from Black Hill State. You mentioned in your discussion about, primarily about a lot of things about consciousness. And
yeah.
Now, that the models that you are using to do that, lot of, modern computer scientists use, multi-state computation, and the phenomena of, quantum decoherence.
Yeah, yeah.
So, but that is so complicated, right? The phenomena of decoherence. It.
I got you. Okay, so first of all, computer scientists have this word complexity. Robert Rosen, student of Brzezinski, theoretical biology, University of Chicago. Okay, Robert Rosen defined complexity to be anything that's not computational. So we have, first of all, this issue of can we as computer scientists or as scientists agree that there's the artificial, Minsky. There's the artificial sciences. The artificial science is about things that are not natural. The square wave is not natural. We've engineered computers to do certain things. Now, Sir Roger Penrose makes the argument that through Gödel, it's Gödel's arguments actually, completeness and consistency, you're not going to find deterministic models of things that are emergent. Okay? Routes to chaos, etc. You're not going to get there. But we can see there's all kinds of non-Newtonian things going on in this room. Okay? So what's Newtonian, what's not Newtonian? So I would say it's complicated if you look at it from the computer science point of view. But I would also say, as Rosen would say, computer scientist does not deal with complexity. Natural systems deal with complexity. Complexity is a halting condition. Right? Complexity is say, I do not know where to go. And biological systems use complexity very powerfully. There's no free will expressed if I'm not overcoming the halting condition. Now that's Penrose's argument for the Emperor's New Mind. AI is an emperor, it's a robe, and there's no robe. The emperor's naked. Oh. You liked that, didn't you, Ed? Yeah. All right, so the discussion period, we've got some time here. So any other comments, Ed, any more? Okay, and I know we have a little bit of time. Thank the Lucas Foundation for, you know, he does this from his own heart. And it's a very significant thing that he does every year for the R.L. Moore Legacy professors. And it's a wonderful privilege to be here.